Hello, my name is Joan Rick. The following will be a presentation on force field analysis with an emphasis on application in risk management. Force field analysis was originally developed by Kurt Lewin in the 1940s for his work in social psychology. It gained popularity in the 50s and has become an important management tool. It is often used for strategic decision-making and change management. However, it can be modified to be a significant tool for use in risk management as well. Force field analysis can be thought of as an enhancement to the standard pros versus cons list for decision-making with which we're all familiar. You take your positive factors, or pros, and list them on one side. You take your negative factors, or cons, and list them on the other side. Then you add up the totals and compare them. Well, force field analysis improves on this concept by assigning each factor a value from 1 to 5, which is based on its importance or impact to the decision. This produces much more accurate totals for comparing the total weight of the negative factors versus the total weight of the positive factors. Steps to implement force field analysis are basically as follows. Establish the decision to be evaluated. Identify the forces for change, or the positive influences. Identify the forces against the change, or negative influences. Assign each factor a value from 1 to 5 based on its importance or impact. Map the insights on a force field chart, and implement the decision. Let's look at a basic example. In the middle of the page, you can see that we have a decision to be made. On the left, we are going to list all of the forces for that decision, or the factors that would guide us toward making that decision. On the right, we're going to list all the forces against the decision, or those factors that would lead us to think maybe we don't want to go ahead with this route. We then assign each factor a value from 1 to 5, and we add up the totals. In this example, you can see that on the forces for side, we have a total of 10, and on the forces against side, we have a total of 7. This would generally lead us to think that our forces for the decision outweigh the forces against the decision, and we're probably going to go ahead and decide to make that decision. Okay, now let's look at a risk example with the weighted values. In the middle of this page, you can see that our decision to be made is whether or not to hire additional temporary staff if our schedule falls behind by 15%. In the forces for column, we have a few factors. We will be able to finish the project on time if we make this decision. We will have a decrease in staff burnout, and we will be able to evaluate these workers for possible future employment. On the forces against side, we've got a few factors as well. There will be a cost increase. There's the time that it will take to orient the staff to the project. And there is an unknown of the productivity level of the temporary staff. Now let's assign the values to our factors. Finishing the project on time is very important in this instance, so it gets rated as a 4. A decrease in staff burnout also is important, but not quite as important as finishing the project on time. That gets rated a 2. And evaluating workers for possible future employment is a nice plus, but not really necessary to the project, so we rate that as a 1. On the other side, we have the cost increase. Fairly important, but not as important, again, as finishing the project on time, so that gets rated as a 3. The time it takes to orient the staff is minimal. That gets rated a 1. And the unknown productivity level, a small concern, but that gets also rated as a 1. When we add up our totals, we come up with 7 for the forces for side and 5 for the forces against side. So we would likely decide to go ahead and hire additional temporary staff in light of the fact that our forces for making that decision seem to outweigh and are more important to the project than the forces against making that change.